I want to talk to you guys today about simple machines, all right? And they call them simple machines because they're simple, all right? That truck is a machine. It's not a simple machine. It would have hundreds or even thousands of parts. All right, a simple machine, some of them might only have one part, but they're very simple, okay? Here's what I want you to get out of today. Simple machines are used to gain a mechanical advantage, and you're going to see what a mechanical advantage is in a couple minutes, an easier way to do something. All right? It's mathematical. I'm going to give you some math problems you can figure out before it happens what's going to happen. Okay? It's mathematical, the relationship of the mechanical advantage. All right? And there's always a trade-off. You don't get something for nothing. So if you're getting a mechanical advantage, there's some disadvantage involved with it too. Okay, a mechanical disadvantage. All right, the first one we're going to look at is a lever. Okay. A lever is like this. It has a fulcrum here that it pivots on, but it's no more than a long bar. This is a lever. And right now there's no mechanical advantage. I push down, the other end goes up. All the lever's doing is changing direction of force. All right, let's have a volunteer here. Okay, jump up here. And we're going to put some weight on there. Go ahead and get on the end of the lever down there. Don't move it, please. Let go of it. Okay. Now, right now we have 20 pounds on it. You want to see if you can pick that up? All right, she can pick up 20 pounds. When she pushes get clear out on the end of the lever, please. Push it down about a foot. All right, that goes up about a foot, doesn't it? All right, go ahead and put it down. Now we're going to add some weight. All right, now we've got 40 pounds on there. You want to try that? Okay, she can still do that. Let's grab some more weight. Where did I put the other weight here? Over on the trailer. Let me grab that. Okay, now we have 60 pounds. And she can't get that off the ground, right? All right, now we're going to do something. Go ahead and pick the lever up. And we're going to change the fulcrum. All right, remember we called this the fulcrum? And if we look at how this is painted, you see the yellow part here? The green part here is twice as long. So we have a 2-to-1 mechanical advantage. All right, so this is where the mechanical advantage in the math comes in. All right, go ahead and try and push that down. Okay, she can lift that easy, right? Before she couldn't lift it. Now, we said there's always a trade-off. All right? And the trade-off is, go ahead and push that down a foot. Does this go up a foot? No. And with a 2-to-1 mechanical advantage, we can lift twice the weight, but we only move it half as far. Okay, you want to run it up and down a couple times? She can lift it, but she has to move it twice as far to get it to come off the ground. All right, set her down for a second. All right, do you understand the way this is painted? 2-to-1. All right, now let's look at another one. This one is painted 10-to-1. Okay, so we've got a 10-to-1 mechanical advantage instead of a 2-to-1. Now let's see who the sharp math students are in here. If I have 200 pounds of pizza right here to put on the end of this lever at a 10-to-1 mechanical advantage, can anybody tell me how much I could lift?
Me?
Yeah.
All the way up.
Okay, how many in pounds? 200 pounds times 10.
Probably all the way.
Somebody, say it. Somebody. 2,000, good job. 2,000. 2,000. That's a ton. I bet I could pick up the back of my pickup. What do you think?
Yeah.
All right, let's try it. Okay, we have a 10-to-1 mechanical advantage. And I'm going to put 200 pounds Now, how far did I have to move it to get the truck 4 inches off the ground? Look at this. I had to move it quite a ways, didn't I? All right. So we got 10-to-1 mechanical advantage, but we also have a disadvantage. Okay? All right. What we have here is a second-class lever. All right, before we had the fulcrum in the center, now we have the fulcrum at the end, okay? The way this works is the part that I'm lifting, the green part, goes all the way to the fulcrum, all right? The yellow part just goes as far as the load. Now the yellow is half as long as the green, isn't it? All right, so we're back to a 2-to-1 mechanical advantage. If that's 40 pounds, I only have to lift 20 pounds here, okay? But look how much I have to lift it. To get it to go a foot off the ground, I have to lift it a couple feet, don't I? So there's that math again, the 2-to-1 relationship, okay? All right, now we'll move the load instead of moving the fulcrum. Now we have a 4-to-1 mechanical advantage. All right, so I only have to lift 10 pounds. Okay, does that make sense now? All right. Okay, if you understand the first-class lever, don't let the rest of this confuse you. But with a first-class lever, we had a fulcrum in the middle, okay? We had force on one end and a load on the other, a weight or something like that. All right, with a second-class lever, we had the force on the end, but we had the fulcrum on the other end and the load in the middle. Okay, so this is a first-class lever. That's the one most people think of. That's the one that picked up the truck. Then we have a second-class lever here, a third-class lever. See if you can figure out what might be a third-class lever. The first one, we have the fulcrum in the center of the lever. The second, we have the load in the center of the lever. The third, we have the force applied in the center of the lever, okay? And then it doesn't matter whether we have the fulcrum and load, doesn't matter which end we have the fulcrum and load. Okay, so that's a first, second, and third class lever. Again, if you had the first class lever straight, don't let the rest of it confuse you, okay? Good. All right, this is a wedge. All right. It's not only a shape, it's a simple machine. And I said some simple machines were so simple they had only one part. A wedge is only one part. Now, if you can imagine these as being metal, you can save me $22 because they're $11 a piece for real ones. But to split wood, you can use a wedge. You can drive the wedge down in to split it, and we're going to split some wood here in a second. Okay? Let's look at the two wedges here. The yellow one is fatter, isn't it? All right, than the green one. Which one do you think would be harder, now listen, harder to drive 2 inches down into a piece of wood? Which one would be harder?
The yellow one.
The yellow one, because it's fatter. Okay? Which one, if we drove them both down 2 inches, which one would give us more splitting force? Would give you more splitting force? The yellow one would, wouldn't it? Because it'd be wider here. So really, this is a little bit different simple machine. The mechanical advantage is determined by the angle, okay? And really, all a wedge does is changes direction of force. We hit down on it, and it pushes out, okay? And I'm going to do a couple pieces of wood where we're going to hit down on them. This is an axe. It's a wedge shape, isn't it? All right, what I want to do this for is so you can see what direction the wood goes after it's hit. You ready? Okay, what direction did the wood go? Yeah, in the pink back there. Out, didn't it? The axe came down, but the wood went out. Let's do it again. Ready? Okay. Whoops. I'll do one more because it's fun.
It is. It's fun. I like to do a split.
Okay, here we go. All right, so that's the wedge. Force down, changes direction of force out. Okay? All right, the next simple machine is a wheel and axle. And usually we think of a wheel and axle like this, something we use to overcome friction. If we took that wheel off of there and pushed, that'd be a lot of friction, wouldn't it? All right, so the wheel and axle here are overcoming friction. Now, you can also use a wheel and axle to get a mechanical advantage, and I'm going to show you that in just a minute. Before we do that, can anybody see one of the simple machines that we've already talked about in this wheel? Yeah, a lever. All right, what would the fulcrum be on this lever? Yeah. The axle, yeah, the middle of the wheel. All right, so we've got the fulcrum here, force applied here, load here, so this is a second-class lever. All right. Now, let me ask you this. Let's say we have a great big stone. Would it make more sense to put the stone here or here as far as making it easy to carry? What would be?
It would be better to put it in the front because then it ain't hard for you to pick up.
Right. If we have it here, you might have a 2-to-1 mechanical advantage. Here, 3-to-1, 4-to-1, I put it right over the axle or close to, it almost picks up itself, doesn't it? Not really, but almost no weight. So we want that as far over the axle as we can get it. All right, now wheel and axle, we're going to have a little contest. Okay, so you guys are going to have to get up. Okay, let's have a couple girls that are about the same. Okay, you two, right there. Come on up. We're going to have a contest. One of you get on the yellow wheel, one of you get on the green. Let's put this pointer straight up. Now, don't put your thumbs inside the wheel, because if the person's going to try and turn it the other direction, all right, I don't want anybody to get their thumbs hurt in there, all right? Now, you're trying to turn that indicator towards the truck. You're trying to turn it that way, okay? Are you ready? I'll go 3, 2, 1, go. 3, 2, 1, go. Okay, she already got it pointed that way. Let's have 2 more. Okay, you 2. You're going this way, you're going that way. You're going that way. 3, 2, 1, go. Oh, yellow one again. 2 more. You 2. 3, 2, 1, go. Oh, yellow one again. You think this is a coincidence?
No, because the yellow wheel's bigger than
Yes, the yellow wheel is bigger than the green wheel, so it's easier to move, all right? It's easier for this person to move the indicator than that one because they have more what?
weight, like
Not weight. It's a word we've already used.
force,
Starts with an L.
load,
Lever. Leverage. It has more leverage. All right, now let's look at that word, leverage, 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 lever. All right, it's a lever, right? If you look here, I painted one of them red. If we cut the rest of that wheel off, this person has a longer lever than this person. That's why it's easier for this one to turn. All right, now if we were going to lift something, all right, let me get something to lift. All right, if we're going to lift something, it would be easier to lift here, but let's say I'm just going to go like this on the wheel, it would be faster over here, okay? So we have leverage, but there's always a trade-off. This one would be easier, that one would be faster. All right, what we have here is a super sophisticated, ultimately accurate fish scales, all right? We're going to use that to do a demonstration here. And I'm going to pick this up with the fish scale, and I'm going to have you read it in pounds. All right, and you see how that reads down? That would be 2 pounds there, okay? We'll hook it in here, and to pick it up, how many pounds is it?
14 pounds.
14 pounds, all right? So with the weight and that on there, it's 14 pounds. If I wanted to put that in a pickup truck, I have to lift 14 pounds. Now, let's try it with an inclined plane. All right, look out there. I'm gonna hook on, and I'm gonna have you read it as it's going up. About 8 pounds, all right? About 8 pounds. So it took 14 pounds to lift it straight up. It took about 8 pounds to go up an inclined plane. All right? Let's take a longer inclined plane. That one is 5 feet long. This one is 10 feet long. What's that one? 4 pounds? Does that make sense? This one's twice as long as that one, and it takes half the effort. Remember we said it's mathematical, right? Okay. So an inclined plane had you use less force, but what's the trade-off?
The reason why it's straight is because it's longer, and the longer it is, it's going.
Right. The longer it is, the less the slope is more gradual, right? Okay. So that long inclined plane makes it easier, but it also means we have to travel farther. So that's the trade-off, and it is mathematical. All right, this is an auger, an ice auger, but it kind of illustrates what we want to do here. Sheldon told Leonard that he was like an inclined plane wrapped helically around an axis. Okay, he was screwed. All right, this is a screw thread, and this one's a great big one so we can see it, but it is just like an inclined plane, isn't it? We could take a matchbox car and go right up the inclined plane, couldn't we? It's just going around in circles. All right, now, screws do two things. One, we can gain a mechanical advantage, and I'm going to show you that in a minute. They also can change rotary motion to linear motion, and I'm going to show you that too. Let's have people that haven't volunteered for anything yet, haven't done anything yet. Okay, let's have you two guys jump up on the trailer. Yeah, you two guys are about the same size there. Jump up on the trailer, come on around here. Let's go. All right, we're gonna have a race. You get at this end, you get at that end. We're gonna turn these as fast as we can clockwise, all right? So you're going this way, you're going that way, just as fast as you can. And we'll go for 20 seconds and we'll see who gets this the highest, okay? Set, go. Fast you can, fast you can. Stop. Who's higher? Yellow?
Yeah.
All right. Let's have two more people about the same size. You two guys. All right, jump up there. Let me get this back so it's a fair fight. Yeah, we got a kind of small circle, didn't we?
Which way do we go?
Clockwise. So it's that way. Yeah. Yeah. You're going this way. All right. Set, go. Stop. Who's higher?
Yellow.
Yellow again. All right. Let's have just two more. Last one. Coach Teeters, get me two more.
Jeremy. All right.
Somebody already done it?
Oh, did Jeremy already?
Yeah.
No, I didn't. No, I don't think he's had a chance.
Okay. This guy's figuring something out. He went right to the yellow. All right. Ready, set, go. Okay, stop. All right, let's look at this for a minute. We said that a screw could do two things, right? One, change rotary motion to linear motion, and you see that. They're cranking up here, but this is moving up here, okay? We also said you can gain a mechanical advantage. Yellow won every time, didn't it? You think it was a fair fight? Nope. What could be the difference between the two? Why did yellow keep winning?
Because
Oh, I tried to get them level. Well, let's look real closely here. You see the threads here? There's fewer threads per inch here than there is there. All right? There are 13 threads per inch here and 20 threads per inch there. So to get it to move an inch, he only had to turn it 13 times. He had to turn it 20 times. It was faster on the yellow side, but if we put some weight on there, what do you think the trade-off is? Which one do you think will be easier to turn? This one, you are correct. All right, this one's easier to turn because it has more threads per inch, and the inclined plane is shallower. All right, so which one of these is like a long inclined plane and which is like a short inclined plane? The one with a lot of threads is like a long inclined plane, isn't it? All right, it takes farther, but it's easier. Here is faster, but it's harder. All right, so there's always a trade-off, and you can gain mechanical advantage by what threads you pick. Okay? This is our last simple machine. It's a pulley. And just like before with the lever, all we're doing is changing direction of force. All right? We pull down, the weight goes up. No real mechanical advantage, but we're changing the direction of force. All right? You want to see if you can lift that? All right, so you can lift that pretty easy. All right, let's unhook it. Since that was pretty easy. All right, go ahead and, it's getting a little harder, isn't it? All right, let's put one more on it. Okay, go ahead. Dang gravity. All right, so she's at her limit. She can't pick up the 40 pounds here. All right, we're going to do something to help her. All right, we've added a pulley now to gain a mechanical advantage. And the way we configure mechanical advantage with pulleys is real easy. We've got one rope that we're pulling on and two ropes that are pulling up. You want to try that one? Okay, still not real easy, but she's able to pull it off the ground, right? Okay. We've got a 2-to-1 mechanical advantage. So if there's 40 pounds on there, how much are we actually pulling?
60.
How much effort does it take?
30.
20. 2-to-1's half, okay? So 2-to-1, it's half. There we go. All right, now, if we can add one pulley, have two ropes pulling, and get a 2-to-1 mechanical advantage, what do you think we could do with this guy? There's 8 pulleys, okay? One rope that you pull on, and 8 ropes that are doing the pulling up, okay? All right, now we have an 8-to-1 mechanical advantage. One rope pulling down, 8 ropes pulling up. We weighed Miss Peck this morning. She weighed exactly 100 pounds. Okay, how much force at an 8-to-1 mechanical advantage will it be to lift 100 pounds? Okay,
And then what if I didn't have my
we'll leave her up there until somebody can answer the question. How much force at an 8-to-1 mechanical advantage does it take to lift 100 pounds? What is 100 divided by 8?
I don't know.
Let me give you an easy one. 100 divided by 4.
I don't know.
What's 100 divided by 4?
I'm just guessing 112.
Yeah,
25.
25. What's half of 25?
12 and a half.
12 and a half. It takes 12 and a half pounds of force. I can lift her with one hand. All right? Because she's so light. There you go. Okay, do you get the mechanical advantage from pulleys? How you get a mechanical advantage from pulleys? All right, let's spin around here one more time. All right, when we started, you guys listening? When we started, we said we want you to understand what simple machines are. Do you understand what simple machines are? Yeah. They're used to gain a mechanical advantage. Did you see mechanical advantage and how that works?
Yeah.
All right. It's mathematical. We saw that, didn't we? We tried to do a lot of math. You know what? I think I gave you pretty tough questions for the beginning of the 3rd grade year. But now you know what you have to work on, right? All right. And there's always a trade-off. If you're getting power, you're losing distance or speed or whatever. Okay? But there's always a trade-off. You don't get something for anything. Okay, you guys did a good job of listening this morning. Thank you. Hopefully you got something out of it. All right?